But at the time of the deployment, we found like the proof generation is like too slow. Even we use like very large AWS instance is still like very slow, which like inspired me to design some specialized hardware for that. For instance, like I want to say like transfer probably like 10 bucks online, but I need to prove to the chain or like to some like authority that my bank balance is like more than $10. So like I can prove that part, but without releasing the exact balance number in my bank account.
What are the implications of this technology? Is the ability to selectively disclose specific bits of information about yourself over a digital space, which is, historically really hard to do because you produce so much data when you're over the internet.
Since like in ZK, like you don't need to trust anyone, like you just trust the math, and the math like you can do it by yourself. And we are not creating like a honeypot like for the hackers to hack.
Hi, everyone. You're listening to the Blockchain Socialist podcast. I'm Josh, and I am here today actually in potentially my new studio that I'm going to be using going on into the future. So more news on that I will share soon. But before I go into that, I wanted to introduce my guest for today. His name is Leo Fan, and he is the founder of Cysic, which is a super interesting project building called an on-chain compute network. But before I butcher trying to explain it, maybe Leo, if you want to give a quick introduction to who you are and what Cysic is.
Yeah, sure. My name is Leo Fan. Like I got my PhD from Cornell, like in cryptography. After Cornell, like I did some research engineering job at NIST and Argument, then started as an assistant professor at Rutgers. So when I was at Argument, like we delivered the first ZK bridge between Argument, Ethereum, Argument, Solana. But at the time of the deployment, we found like the proof generation is like too slow. Even we use like very large AWS instance is still like very slow. So which like inspired me to do something to like probably like design some specialized hardware for that. So the word like Cysic is a combination of two words. The first is like cipher, and the second part, the SIC, is like coming from like ASIC. So it's a combination of like building some specialized hardware for cryptography. So that's like how we like started Cysic. And like while doing Cysic, like we do a lot of things. Like we do like the GPU and FPGA acceleration, and we also did some like work on ASIC design for ZK.
So maybe just to help listeners, just in case they don't know what some of these terms mean, ASIC is an application-specific integrated circuit, if I'm not mistaken. It's kind of like specialized hardware. Often you hear about it in the context of mining Bitcoin. You get ASICs hardware in order to mine Bitcoin really, really well because it's a specialized hardware that's really good at specifically the thing for mining Bitcoin, for example. And then, if I'm not mistaken, cipher is also a cryptography term.
Yes.
That I believe is like, if I'm not mistaken, it's the key? Is the cipher the key in like a cryptographic secret kind of way to explain it?
So like in the encryption part, like the encryption will turn in this like plain text into ciphertext. So ciphertext is an encrypted plain text.
So ciphertext is kind of like the secret itself, I guess.
Yeah.
So jumping off a couple of levels from, assuming you guys understand a little bit about cryptography, which is just the math around sharing secrets and saving data and memory for computers. Zero-knowledge cryptography, or ZK cryptography, is a different type of cryptography that's a little bit more advanced and is kind of on the bleeding edge of things. Maybe you can explain a bit what is zero-knowledge cryptography and why is it expensive to generate and use right now?
So we can like treat the ciphertext we just talked about as an encryption or like some representation of the plain text, but in the ciphertext way. So like for ZK, you can think about so ZK to computation is what ciphertext is to plain text. So like we basically compress a lot of like a computation into a like very tiny base string, and this base string will represent this like computation, but this string is not like the hash string. It still have some like structure inside, which will enable people to trust you if they verify that the bit string will handle to then satisfy some requirement. So that's like how you can say the knowledge part. So it's like a representation of the computation you just carry out. Yeah, and why it is like useful, it has like two nice properties. The first one is the knowledgeless, and the second one is the succinctness. The knowledgeless means like it will preserve the privacy and without releasing the private part like to you. Like for instance, like I want to say like transfer probably like $10 online, but I need to prove to the say to the chair or like to some like authority that my bank balance is like more than $10. So like I can prove that part, but without releasing like how like what's the exact balance number like in my bank account. So like I handle you this like ZK proof, and you can verify and then trust that my bank balance is larger than like $10, and then you can do the transfer. So that's the knowledge part. The second part is succinct. So the succinctness means like the proof is like very short. It's probably like several hundred bytes or several hundred kilobytes. So it's a very small proof, which like you can use a proof to encode and like very large like computation. So that's the first part of the succinctness. The second part is, although the proof generation is like takes a lot of time, but the proof verification is like super fast. You can verify ZK proof on your cell phone like in less than 15 milliseconds, and with a very little computing resource, then you can do the verification. So like at Cysic, we have this like My Cysic app, which you can download it and then to verify the proof we generated like in part of our network on your cell phone. Yeah. So that's like two nice properties, that they are knowledgeless and succinctness of like ZK.
Right. Yeah. I think one of the ways that I've also heard people try to explain zero knowledge proofs is the example of, like in the United States, for example, where if you want to go inside a bar, you have to show your ID, your driver's license, and you give your driver's license to the bouncer, and he not only sees that maybe you are or are not old enough to enter, you're above 21. They know exactly your birthday, they know your full name, they see your address, they see a lot more information than maybe they necessarily need to know. So this kind of it allows you to say to the bouncer, I'm over 21, without giving any other information, without getting any leakage of unnecessary information. So it's kind of like a way of doing selective disclosure, I guess. This is the zero knowledge part, at least, aspect of zero knowledge proofs. And I think that's why it's interesting from a what are the implications of this technology, is the ability to selectively disclose specific bits of information about yourself over a digital space, which is, historically really hard to do because you produce so much data when you're over the internet, and everybody, if you own the platforms, or if you own, a lot of the piping between everything, then maybe a bit more, or you've given out more information than you intended to give out.
Right. Yeah.
Yeah, and then succinctness, it's also good for compressing data, I guess.
Yes, yeah.
It's kind of how I think about it.
Yeah.
But are there any maybe specific real world examples of zero knowledge proofs and cryptography kind of in use that the average person may be able to relate to for you?
Right. Yeah. So we all know like both Bitcoin and Ethereum, they're like public ledger, where like all people can check like the balance, or like how many coins they have like in one wallet address. But there is some privacy oriented blockchain, such as like Zcash or Alio. They if you do they can basically shield the number of like tokens like you have in your wallet, so that people cannot check the exact number, and all the transfer probably I would say 80% of the transfer they also happen privately, and which preserves some privacy of the traders or some other guy who use the blockchain. So that's like on the knowledgeless part. And the second part is on the succinctness. We can use the succinctness like to scale up a lot of blockchain. So like for take Ethereum for instance, like if like how Ethereum like validates the transactions that they execute all these like transactions in Ethereum. So that's like which is like why they put a gas limit for say like for a block. But in instead of like re-execution, you can generate a ZK proof. Where like since like a ZK proof is like one proof you generate and everyone can verify it, and then if it passes the verification, then they will like trust like the statement in this proof is true. So instead of like re-execution, you can just verify some ZK proof, which proof that all the transactions they are like valid. And the verification of like the ZK proof takes a very small gas. So which means it will increase the gas limit, which you can like have like more transactions in one block like for Ethereum. So that's like two nice applications of ZK in blockchain.
Right. Privacy and scaling. I think what's important to understand for a lot of for some users, at least when I've tried to explain cryptography for them, is that like a lot of cryptography can be used for both privacy and scaling, and that they're kind of like
Competing with each other.
the same property. Yeah, like the same property of this math that you're using in these systems can be used for like things that you don't think are related, but they end up being related in these types of systems, which I think is really interesting. It's kind of like when I realized that, I was like, oh, this is why it's like, quite expansive what you can think about doing with this.
Yeah.
So you mentioned that like ZK proof generation is fairly expensive, or it's costly. It's kind of slow. It's still a type of technology that people are figuring out how to do better, faster, etc. But I'm curious why. Where does that like cost come from? Why is ZK proof generation so much slower than like say other forms of cryptography that we're already using today?
Yeah, so like I guess other crypto tools like we are using today is like encryption, digital signing, and also probably like some hash functions. So like compare against these tools, the data handled by ZK pool is like way much longer. So like a typical ZK statement will handle this like degree of like very large degree polynomials, and the degree is usually like 2 to the 24 or something. So it's a very large polynomial. And the coefficient for this polynomial is also 256-bit long. So it's a large polynomial with a lot of like data in there. And handle this kind of polynomial will require enormous computing resources to do that. And also the computing resources, like when they do the process, they also need to like communicate with each other, which means like you also need to a very high bandwidth to support the transmission of the data between this like processing units. So that's the like two most important parts in the competition, like very large computing resource and a very high bandwidth to support the processing. So which also explains like why like it's quite expensive to generate a ZK proof. You need to have a machine that's like powerful enough to do both things like very efficiently.
Right. So it's just basically it's more math.
Yeah.
is the
Yeah.
is the simple answer.
Yes. Yeah.
Bigger numbers.
Yeah, bigger numbers
take a longer time.
Yeah, bigger numbers takes longer time to both like compute and also to transfer the thing.
Right. So I guess so. This kind of like my understanding, at least, is that then, like your average computer hardware is not necessarily built at the moment to be generating zero knowledge proofs.
Mm-hmm. Yes.
And so I guess this is kind of why, if I understand correctly from what you guys are doing, that you guys also provide hardware, like a network of hardware for people to use to generate these proofs. Yeah, do you want to talk a little bit more about the hardware side of things?
Yeah, sure. Cysic is a compute file network. So by compute file, we means like we turn this like computer resources into some early machines for you. You can plug in your like servers, your laptop, or even your cell phone like into our network to do something like in the computation. And of course, like we categorize we categorize this hardware into the different groups, which is like responsible to do different things. Like for instance, if you plug in your like server, probably like is powerful enough to generate some ZK proof in a short period of time. And we also use these like servers to do some like AI inference for us. So that's like the server side. If you plug in your like laptop or even your cell phone, which is like not powerful enough to do the two things I just mentioned, like then we assign this like ZK verification, AI verification job to you, which like your not very powerful computing hardware still can handle that, and also some like yield, and all the things will run in the backend, so you won't be able to notice any difference like in using your hardware. Yeah.
Right. Yeah. So there's generation, the proof generation, which is taking in all the inputs that make up your zero knowledge proof, and depending on how you're like setting it up, you generate a proof, which is like kind of a reference to all these inputs and gives you a kind of answer, but then that answer has to be verified by the person that receives the answer to double check to know that this proof is saying what it's claiming to say. And if I understand correctly, the generation is much more compute intensive than verification.
Yes. Yes, that's right.
So there's these two types of compute. Verification, if you got probably any probably laptop or phone can do verification. The generation maybe you can do, but it will take a lot longer than like a beefier machine. But you guys are basically, if I understand correctly now, then you guys are creating a kind of network where anybody can bring whatever hardware they got, and they could potentially make a little bit of money off of it because other people are paying for the verification and the generation of ZK proofs on the network.
Yes, that's right. Yeah.
Nice, it's super cool. It reminds me of, I don't know if you remember one of these early. I think that was Golem. Maybe it was like one of the first kind of attempts to do something like this, if I'm not mistaken. I think there are other ones. It reminds me of like these proof of useful work blockchains that you used to have back in like 2017,
Kind of,
16
yeah,
maybe.
yes. Yeah, so that's
Really?
like, yeah, so at that time, like people were saying like all this like Bitcoin mining is like a waste of computing resources. It's like you produce some like specialized hardware which will also cost a lot of like electricity in computing the hash. So people think like probably instead of doing that, like we can use like the resources, whether it's like in electricity or computing power, to do some like real jobs for human being. Yeah, so that's the time like in 2014 till 2017, I think. Yeah, so since
Yeah.
like my like before coming to Cornell for PhD, and like I did some like Bitcoin mining uh back then. Yeah, for several years. So like, and the idea of like using some specialized hardware to accelerate the case also, as you mentioned, like this idea was also inspired by Bitcoin mining.
Okay, nice.
Yeah.
Is actually which network does Cysic connect to? Which blockchain networks?
Yeah. So right now we are like proving. So it also depends on the market. So probably like last year, like Cysic is the biggest prover for like several large like layer tools, including Score, zkSync. Yeah, since like these layer tools, their job is to scale up Ethereum, so they generate a lot of like transactions, and they need also, which means they need a lot of like computing resources, like to generate the proof for them. And like so, for instance, like we successfully like reduce the proof generation time from like 1.5 hours to about like 20 minutes on a uh, two 4090 GPU card like machine. Yeah, so that's why like so this like layer two, they want to work with us to reduce the burden of like generating zk proofs. But like so that's like something that's a situation for next year. But as you can see, like all these layer twos, they are not doing very well right now. Yeah. So like we shift like some of our computing resources to support Ethereum and also to support some perp decks. Yeah, these perp decks, they also need to generate a ZK proof for each transactions on their decks. So like so that's also like a very large number to not large number of like ZK proof to generate.
Okay. Are these perp? Do they verify those zk proofs on chain, or are they just generating a proof?
So like our process is like we like say we can talk about the lifespan of like a zk proof in Cysic network. So like
Yeah.
for each like task we receive from say like this like perp decks, we pick like several like random proofers to generate the proof. And then like we pick a large number of like verifiers, which like on your cell phone or on your laptop to verify the proof. After a proof is like verified, say by 8 out of like 10 verifiers, we call it this proof is like settled. Then we put it on Cysic network. And also additional like we send the verifier proof to the perp desk. So the proof is already like settled in our chain, and some of the problem like I guess the perp decks or like they don't have the energy to verify like each proof. They just do some like sampling on the proof already settled by us, like to check the validity of the proof. Yeah.
I see. Interesting. So you have like the network also has a level of kind of redundancy, I
Yes.
guess, where you want to you want to be able to have trust in the proof, and so you have a few at least people run the same proof or verify the same proof to make sure that it's valid.
Yes. Yes, that's right.
Yeah. So maybe we could talk a little bit more about ComputeFi. I think it's interesting. I think there is like this uh, general. I mean, I've never really engaged with any of this, but I've seen some stuff of like, people trying to financialize a bit of their like the compute on their computers to sell that as like future compute used in AI inference or something like that. I'm wondering if you can explain a bit like how do you see ComputeFi? What is it, and like what does this future hold for us?
Yeah, so as you can see, probably like there are like several also similar platforms such as like IO.net or some others. So but they are like the IO.net or like some other, they are just creating a platform where like people plug in their servers there and wait to be like rented or like used by others. So it's basically like AWS or like Vast.ai, this kind of platform, but they are in the blockchain or crypto world. So like Cysic differs from these competitors in a very significant way. So like in addition to creating this kind of like platform, we also bring some like real jobs to be computed by the servers like inside the network. Say like for instance the liquid proof generation is like one thing, and also we have this like a lot of like AI products on Cysic network which also consume the tokens is like generated by the underlying machines. So like in addition to just creating a platform, we are bringing some like real jobs for the servers on Cysic network to process. So that's a very big difference. Yeah.
So do you think like in the future, one potential? Well, I guess the thing that kind of you're describing, just to step back a bit, is almost like a, this almost like a meme to me, but like this meme of the decentralized cloud, so to say, of like computes or computers being able to connect from anywhere to take part in this network and to provide that infrastructure in a way that is resilient and redundant,
Yeah.
at least at par with other types of cloud providers, and that people would be able to kind of like you know have almost like have like make money off of the data center you have at home.
Yes. Yeah. Yeah.
Rather than necessarily the mass build out of giant data centers that's maybe going on right now. Maybe one alternative is we could use the excess computes that we already have available to us with everyone's consumer hardware, rather than needing to overbuild all these amounts of data centers. This could be one kind of alternative to that.
Yeah. Yes, that's right. Yeah.
So yeah, are there any other? I guess are there any other non-blockchain related ZK examples that you're particularly interested in?
Right. Yeah. So like as you mentioned before, like the ID thing is like one very good example. Like in addition to showing up like your ID, you can just generate a ZK proof, saying like you are like older than 21, then you can enter the bar. And another example is like there are some events like say like probably like last year or the year before last year, there is a DEF CON in Thailand. And when like if you are like a local like in Thailand, then you can apply for a special discount on the ticket for that event. And how you like prove you are like a local, like it's like previously it's like you just upload your passport and then you are showing like you are local. But like that will reveal a lot of information you don't want to reveal. So like very nice way of like using ZK to wrap around it. Like you download a software and then you generate the ZK proof of your passport showing that you are from like Thailand, and then you upload only the ZK proof to the TK website, and then after they verify it, then you can get the like special discount. Yeah, so that's
Right.
yeah, it's basically digital ID, and you can use a digital ID like to do a lot of like things. Yeah.
Right. And this is like, I mean, this is super interesting to think about just in the current context with the amount of legislation that's being passed right now, requiring people to prove that they're, over 18 or whatever to use certain platforms over the internet. I mean, it is something that is being pushed. Different people have different views on like whether or not it's like the right approach to kind of actually solve the problem that they think they're trying to solve around protecting kids. And so, yeah, I mean, ZK. What is interesting to me is that, like, at least as far as I could tell, a lot of the technical specs of a lot of these identity solutions from, I think, particularly like the UK and Australia, I know had some, and I think the US is working on something, but these identity solutions don't include ZK, as far as I know, which is interesting because you would think that if you actually wanted to solve the actual problem
Yeah.
that they say that they're trying to solve, while also not causing any externalities, aka creating a giant honeypot of people's data in someone's databases, like then zero knowledge proofs should be like your first. That should be like one of the first things you should be considering,
Yes,
right?
yes,
Right?
yeah. So like we are pushing like the VK public to the traditional world or like the mainstream to make people aware of that, and then like to use it. Things like in VK, like you don't need to trust anyone. Like you just trust the math, and the math like you can do it by yourself. And we are not creating like a honeypot like for the hackers to hack. They are just the ZK proofs, and ZK proofs are like due to the nice properties of ZK, you basically cannot get anything out of like of the ZK proofs there. Yeah, it's like more reliable, more transparent, I would say, like compared with the current solution. Yeah.
Yeah, right. Um, so yeah, I don't know. Call. I think it's like we're at a really funny stage in politics almost where like, it's like call your senator and teach them about zero knowledge proofs because
Yeah.
what they're proposing right now in this legislation like is not privacy preserving at all. It like really highly depends on you know
Yeah.
someone to build a database that is like just going to get hacked. It's not a matter of if, it's a matter of when, you know?
Yeah. Yeah. It's just a matter of time to hack this kind of database. Yeah.
Yeah. Go to your capital and teach your government officials a little bit of math, a little bit of zero knowledge cryptography. Um, but yeah, thanks, Leo. Are there any other last things that you wanted to mention before we close it off?
Something like we also want to mention is like we open source like the ZKVM uh, code repository. Like you can try it out, and we have a lot of like products on Cysic. You can just check out like Cysic .xyz for like for our products, and then you can follow us on Twitter. Like it's CYSIC-XYZ to for the latest updates like from our team. Yeah, so we have a lot of like interesting products ongoing.
Cool. And how can people right now today be able to join the network to be able to make a bit of money off of their hardware?
Yes, yes, it's like total permissionless. Like you can use your like even if you don't have a very powerful server, you can always use your laptop or even your cell phone to join. You can download like my Cysic app on your whether it's like Apple or like Android phone. You can always try it out.
Cool.
Yeah.
Great. Well, thanks, Leo, so much for coming on and appreciate you explaining zero knowledge proofs to us and sharing about Cysic.
Thanks a lot. Thanks a lot for having me here. Yeah, I had a very nice conversation. Yeah.
If you like what I'm doing here, consider supporting the show on Patreon. Your contributions help me keep doing this work and dive deeper into the politics of decentralized technologies. I promise you absolutely zero financial returns, no airdrops, and your investment may go to zero. But you will get good content. Check out patreon.com/theblockchainsocialist to support the show.